we're going to do problem number 1 to start our 6 weeks review. All right, it says solve the system by graphing. So what you can do, if you don't have enough room on your paper, you can certainly write this in your journal. I have an x plus a y equals 4. And then I have an x minus 2y equals 1. Both of these are in this form called standard form, where ax plus by equals c. Now, just so you guys know, there are 3 cool little formulas you can use. If you ever wanted to find or locate your x-intercept, that will always be your c value divided by your a value. If you wanted to find your y-intercept, that will be your c value divided by your b value. And if you ever wanted to know what your slope was, that will be the negative a over the b. So there's your 3 right there that you can use. Now, in this problem, for the blue, I'll let you know, a is 1, b is 1, and c is 4. Hold on. C is 4. Now, it's pretty easy right now. Another way you could do this is called the Algebra method. Pretty easy. Watch, right? What do you see? What is x equal to?
Nothing.
No, right here.
4.
4. That's your x-intercept. What's y equal to? 4. Well, if I did the longer way using these right here, what is 4 divided by 1? 4. What's 4 divided by 1? 4. So right now what you could do is you could put your x-intercept right here at 1, 2, 3, 4. Put your x-intercept right there at that point. Put your y-intercept at 4 right there. And you could draw your line by using just your x-intercept and your y-intercept. Now, if you don't like that method, you're like, I like to change things to slope-intercept form, you could take this x and do what with it? Just move it across the equal sign, and that gives you what? Y equals negative x plus 4. If you like slope-intercept form, that's great. What's your slope? Negative 1. What's your y-intercept? Positive 4. How do you apply a negative 1 slope? It's negative 1 over 1, which means you go down 1 and over 1. And you'll notice, what does this line do? It goes down 1 over, down 1 over, down 1 over, just like that, all the way down. It's called the constant rate of change, also known as slurry. And your y-intercept is still on 4. Now, this one right here, I'm not going to use this method of using standard form. Let's go ahead and change it to slope-intercept just for practice. We're going to take away an x. That's another way of doing it, or called its additive inverse. We'll take away an x on both sides, and we're left with negative 2y is equal to negative x plus a 1. That's not what I want. I want to know what y equals.
Divided by -2.
Divided by negative 2. Thank you. I totally forgot. It's a good thing it's not my 6 weeks test today. I'm telling you. So we divide everything by oh my gosh, there's a whole lot of negatives. Let me scroll over here. Negative 2 divided by negative 2 is 1, so we just left with the y. Negative x over a negative 2 becomes a half of an x. Because a negative divided by a negative is a positive. And just remember, everybody, x divided by 2 is the same as 1/2 of x. It's important to know that. And 1 divided by negative 2 is simply a negative half. What's my slope? 1/2. What's my y-intercept? Negative 1/2. By the way, if you plug in a 1 right there, if you plug in a 1 for x, you get a half minus a half. If you plug in 1 for x. So think of it. If you had a table, ready? If you had a table, and I said you plug in 1, what's a half minus a half? 0. So plot, right here, plot. 1, 0. That's one of the points that would be on the graph. Now, if you didn't know that, and it's in y equals form, what can you always use? You'll have this tool next to you tomorrow. Not friends, no. No, I'm sorry. Your graphing calculator, which could be your friend, all right? It will not insult you, all right? It's down, up 1, over 2. Not yet. Maybe in 10 years. Maybe you'll type in an equation wrong, and it'll say, no, you imbecile, but not yet. Okay? That would be kind of funny. What the heck are you doing? You're punching in all the wrong numbers. So right now, there's my line. Notice, up 1 over 2, up 1 over 2, up 1 over 2. Now, where the two lines meet is called the, what do we call that? We call that our point of intersection, also known as the solution. So what is the solution of these two lines? 3, 1 is correct. So our solution, everybody, your answer to problem number 1 is 3, 1. And you just graphed it, showing that that was your answer. 3, 1. Now we're going to go to problem number 2. I'm going to clear all this out. We're going to go to problem number 2. All right. There's 2A and 2B. Here we go. It says, graph the system. Y equals x plus 2 and 2y equals 2x minus 4. Now, one of these is really easy to graph, and one of them is almost just as easy. Okay? Which one is the easiest do you guys think? The blue or the red? Yeah. Why is this one the easiest? Because it's already in what? Y slope intercept. All right, what's my slope for the blue? 1 over 1. What does 1 over 1 mean? It means I go up 1, everybody, and I go over 1 to the right. What's my y-intercept? 2. So we're going to go over here. We're going to put a point right here on my y-intercept. 2. Notice there's my origin. There's 0, 0. Go up 2. Now I apply my slope. I go up 1 and over 1. Oh, I ran out of room, so I can go down 1 and over 1 to the... There's my line, everybody. Connect the dots. Voila, there you go. Okay. Now, oh no, I don't know what y is equal to over here. What should I do? Oh, okay. So glad somebody knows what to do. 2 divided by 2 is x. Negative 4 divided by 2 is negative 2. Interesting. I've got a slope of 1 and a y-intercept of negative 2. My slope is still 1 over 1, which means I go up 1 and over 1. But my y-intercept is negative 2.
They never cross.
They never cross because the slopes are the same. And lines that have the same slope are considered to be what to each other? They are parallel. And parallel lines have no solutions. So whenever you guys get this answer of no solutions, is it consistent and independent, consistent and dependent, or is it inconsistent? Inconsistent is correct. So what you're going to do for 2b right here, you're going to write words inconsistent. All right? Inconsistent. Now, what do we call two lines that intersect? We call those consistent and independent. What do we call the same line twice? Consistent and dependent. Here you have one solution. Here you have infinitely many. You have like all their answers are right. That's the same line twice. Okay? All right. We still have some time. Let's go ahead and look at number 3. Number 3, it says do what? Use substitution to solve the system of equations. By the way, do I know what y is equal to in this particular case? Y is equal to 2/3 x minus 2. So I want you to take this right here and plug it in for y. So here's what it would look like. You're going to have 3. I'm going to open up a big old dadgum parentheses. I'm going to plug in a 2/3 x minus a 2. And what am I setting that equal to? I'm setting it equal to 2x. So go and plug that in just like that. The next thing we're going to do, we're going to distribute the 3 to both numbers. Now 3 times 2 is 6. 6 divided by 3 is 2. And 3 times a negative 2 is a negative 6. This is looking weird. Say that again, Blue. That's right. If you subtract 2x from both sides, you get a whole lot of nothing and a whole lot of nothing. And then you get negative 6 equals 0. And in this universe, negative 6 is definitely not equal to 0. So whenever you guys are solving things algebraically, and you get two numbers that are not equal to each other, that's where you're going to have no solutions. By the way, what's the other answer for no solutions? Inconsistent, right? From 2b. Now, let me show you a different way of looking at this. Okay? Maybe this will make even more sense. Do you guys see right here on problem 3? I know we already did problem 3. It's no solutions. But you see right here we have what? We have 3y equals 2x. Look what happens when I divide both sides by 3. I get y equals 2/3 of x. What does this say? Y equals 2/3 of x minus 2. Notice what is exactly the same right here and right here. The 2/3, they have the same slope, which means they are parallel. Okay? So if you notice two lines have the same slope, you know it's going to be no solutions. Or it could be the same line. How would this be the same line? They'd have the same y-intercept. Okay, so they'd have the same y-intercept and the same slope and then the same line. That's where it's infinite limit. All right. Last problem we're going to do on this video is we're going to zoom in and we're going to practice the elimination method. We have less than 5 minutes to do it, so make sure you're paying attention. Right now, we're going to solve for x and y using the elimination method. My suggestion is whenever you see a negative and a positive, focus on eliminating those numbers. We're going to eliminate the y's, not the x's, because I already have a negative and a positive. So what I'm going to do is I'm going to put parentheses and parentheses. And by the way, the least common multiple between a 2 and a 5, now where the heck did I get the 2 and the 5? There's the 5, there's the 2. The least common multiple between those two numbers is a 10. So what I'm going to do, everybody, is I'm going to take the top equation and I'm going to multiply it by a 2. And I'm going to take the bottom equation and I'm going to multiply it by a 5. Now I'll do two different colors to make it a little bit easier. So we're going to take the top equation and multiply everything by a 2, and you will get 8x minus 10y equals negative 4. I'm going to multiply the bottom equation by a 5. So distribute, distribute, distribute. You get 15x plus 10y. Yay! Equals negative 65. Why did I say yay? Besides, that was weird. Because I'm happy, okay. And because I'm happy because these additive inverses right here, what do? All of the y is eliminated. I know, poor y. It has a good y, but not really. So right now, all of our y's have been eliminated. 8x, 15x's, 23x's. Negative 4 and negative 69 gets me, negative 65 gets me a negative 69. I was thinking the answer for this.
And then you divide it by 23, you get negative 3.
Right. So do what Maddie says. Divide both sides by 23. You get x equals negative 3. There's my x. I just found my x. It's negative 3. What am I going to do with this pesky negative 3? I'm going to plug it back in. Now, which equation do you think would be the easiest to plug in? This one here or this one here? Top or the bottom? I like the bottom too. Here we go. Ready? We're going to plug it in right there. So instead of 3x plus 2y equals negative 13, what am I plugging in? I'm plugging in a negative 3 for the x. Wow, this is so easy. All right, so I plug in a negative 3 for x. Why am I plugging in a negative 3 for x? Because what am I solving for now? Because I'm asking you. All right. 3 times negative 3 is a negative 9. By the way, every math teacher that has ever existed has used that joke. I'm sure they have. It's not a good joke. It's just they used it. Yes. Now, I don't know what to do now. I want to solve for y. I'm so stuck.
You add negative 13 and negative 9.
How is it? Add 9 to this side and add 9 to this side.
Did you get 22?
No.
Negative 22.
No.
Negative, wait.
What do you mean?
Negative 4.
Negative 4, that's correct. There's 13 negatives and 9 positives. By the way, let's imagine you owed me $13. Okay? You owed me negative. You owed me $13. But then, Mr. Moon, here you go. I'm going to give you $9. I'm like, thank you so much. You still owe me 4 more.
Oh my God, no.
Sorry, honey. Well, it's big math.
Okay.
Divide both sides by 2 and y equals a negative 2. So what are my two answers, everybody? Negative 3 and negative 2. As an ordered pair, that would be negative 3, negative 2. You can just say x equals negative 3, y equals negative 2. And what do we use? We use the elimination method. And we almost got it done. We did get it done. Perfect. Have a good day.